Now let's see some points on symbol table. So we are going to especially talk about the theoretical points on the symbol table, and you might get, in case if you are going to get a question, you might get a theoretical question on this. There are no numerical examples, or I cannot take any grammar and give you an example. Just try to remember these points, right? And in case if they ask you any theoretical question, these points will be useful. Now let me tell you all the points here one by one. As you know, a symbol table is a table in which information is going to be stored and used whenever it is required, right? So who is going to store it and who is going to use it and who is going to update it is all the questions. The questions will be all about that. So first thing is, symbol table is an important data structure created and maintained by compilers in order to store information about the occurrences of various entities such as variable names, function names, objects, classes, interfaces, etc. So whenever you are writing a program, then whatever names you get, right, all of those are going to be stored there. Either it could be a variable or a function or an object or a class or interface. Every information about all these entities is going to be stored in the symbol table. The information is collected by the analysis phase of the compiler and is used by the synthesis phase to generate target code. So who is going to create, initially store the information in the symbol table is analysis phase. While analyzing the code or while reading the program, you will be able to find out what are all the entities used in it, and you are going to store all those entities in the symbol table. Later we are going to look into this information in order to generate the target code. So if you look at this, the information is collected by the analysis phases given. Now what is the analysis phases? We have three analysis phases, right? So one is lexical analysis, other is syntax analysis, and the other one is semantic analysis. So all these three phases are going to understand the program that you are going to write, and they are going to store the information, relevant information, in the symbol table. Now usage of symbol table by all the phases of the compiler, I have just given you a simple tabular form so that you will remember it easily. Okay. Now lexical analysis. So how lexical analysis is going to use the symbol table is, it is going to create new entries for each new identifiers. So lexical analysis can identify what are all the names, right? Names means either it is a variable name or a function name or a class, object or interface. They are all called as identifiers, right? So for every identifier, lexical analysis is going to create an entry in the table, symbol table. And the next one is syntax analysis. In the syntax analysis phase, adds information regarding attributes like type, scope, dimension, line of reference, and the line of usage. So all the information related to this, what is type, what is the type of the variable, or what is the scope of the variable, and in case if it is an array, what is the dimension of this, and what is the line in which it is referred, and what is the line in which it is used. So all this information is added into the symbol table by the syntax analysis. And the next one is semantic analysis phase. So in the semantic analysis phase, uses the available information to check for semantics and is updated. For example, if you are going to use a variable a, it's in some assignment, let's say you are writing a equal to 10, right? So we have to check whether it is semantically possible or not. How will you be able to check if you know the type of a? In order to know the type of a, your semantic analyzer is going to get into the symbol table and see the entry for a, right? And it will find out that if a is the name of an array, you should not be able to do that kind of assignment. A equal to 10 is invalid, right? So in order to do such kind of semantic analysis, your semantic analyzer is going to use the symbol table, and also in some cases it might add some more information into the symbol table, right? And the next one is intermediate code generation. So as you know, intermediate code generator is going to add some temporary variables into the code, and in order to add the temporary variables, it might need the information about the original variable. Let us say you have an expression like x equal to y plus z, right? Maybe you are trying to add a new temporary variable like t equal to y plus z. Now in this temporary variable, the type of the temporary variable depends on the type of the result. So what I mean to say is, if you have some statement like x equal to y plus z, Okay, now if you have to add a temporary variable saying that t equal to y plus z and then x equal to t, something like this, you should be able to understand what this t should be, isn't it? And the type of t depends on the type of the result y plus z. In order to understand the result y plus z, you have to find out the type of y and type of z, and the type information is already present in the symbol table. And who has computed it? It is done by the syntax analysis. Type is already stored, right? Therefore your intermediate code generator is going to look into the symbol table in order to get the required information so that it will generate the intermediate code, right? See this. Information in the symbol table helps to add temporary variables information, right? So when you create the temporary variable, what type it should be, that depends on what are the variables. So likewise, all these stages are going to use the symbol table. Let's see the next one. Okay, now the code optimization phase is also going to use the symbol table, and it is going to use the symbol table in order to optimize it. See this. Information in the symbol table used in machine dependent optimization by considering address and the aliased variables information. So what code optimization is going to do is, it is going to take the information present in the symbol table for the optimization purpose like this. So assume that you have taken x equal to y plus z is the line of the code, and now in the target code generation, let's say we have introduced a temporary variable in such a way that you have written t1 equal to y plus z, right, and then x equal to t1, right. Later in the code optimization phase, right, you might want to eliminate this, or at some other point in the code you might have a line like this, right, y plus z somewhere. If you have already computed it once, right, then you could simply replace wherever the y plus z is with t1 or with x, right. So in order to do that, your information in the symbol table is going to be useful. And the next one is target code generation. So while generating the target code, sometimes we might have to know the addresses. The reason is, if I am going to write a of I, right, even though this way of writing is human friendly, while converting it into the machine code or the target code, you have to convert it into a form which is machine friendly. So the machine friendly representation of this one is going to be star a plus I, right, where a is nothing but the starting address of the array a, right. In order to get this, again you are going to look into the symbol table to get the addresses, right. See this. In target code generation, generates the code by using the address information of the identifiers, right. So you will have to replace everything with the addresses finally, okay, in order to get into this target code. Okay, so these are all the usages of various phases of the symbol table. So every phase is going to use symbol table for some purpose. Analysis phases are mainly going to use to update the symbol table or to collect the information and put it there, and all the next phases are going to use the information in order to generate the required data. Okay, fine.